Hey, it's time for Mole Worksheet 5. This is Dr. B, and let's have a look at limiting reactants. Now, I'm going to read this in its entirety, so this might take a few minutes. Fast forward if you want to skip the initial stuff. In nature and in the lab, substances are being mixed together in all kinds of amounts. It's true. How much product will form? Well, here's a typical problem. I mixed together 10 grams of hydrogen with 10 grams of nitrogen under the conditions necessary to form ammonia. How much ammonia can I theoretically make? Well, you probably have silly amounts, right? We're supposed to be mixing 6 grams with 28 grams. Can you see that? 2 times 1, that's a pair of hydrogens is 2, but we need 3 moles worth, so that's 6 moles, or 6 grams, I should say. 6 grams requires 28 grams. And you could check that because those 28 grams plus the 6 make 34, which is 2 times 17, which is 34. Good. Bottom line, we need more than 4 times as much nitrogen, but some bozo didn't give us that much. There's only 10 grams of hydrogen, not the roughly 30 grams of nitrogen that we need. So clearly we're going to run out of nitrogen first. It's our limiting reactant. If you're going to figure out how much product you can make, you base it on that because you're going to have some wasted hydrogen. And that's what we do right here. We take our 10 grams of nitrogen, and we find out how many grams of ammonia it can make. And when we plot it through, we find that it can only make 12.1 grams. I'll show that briefly. It's a 3-step conversion, so you'd set it up, and then you'd go from grams of nitrogen to moles of nitrogen, where 28 grams is a mole. But for every mole of nitrogen, see how there's a 1 in front of that? It can make, we will make, let's hope, 2 moles of ammonia, which each mole weighs 17 grams. Those should be subscripts. And there it is. You have enough to make 12.1 grams. That's wonderful. But sometimes they say how much H2 was wasted. You figure that by how much was needed. Now you could take that 12.1 grams of ammonia and back calculate how many grams of hydrogen it required. That would be one way to do it. And you'd get 2.1 grams. Or you could take that 10 grams of nitrogen and just figure out how many grams of hydrogen that requires. And that's what we did here. It's a very elegant calculation to figure out how much was needed. The rest is wasted. I like it. Well, those 10 grams of nitrogen are all going to get consumed, but the hydrogen is not. And we have 28 grams as a mole, but for every mole of N2, we need 3 moles of hydrogen, but it only weighs 2 grams per mole. So we only require 2.1 grams of hydrogen. Somebody added an extra 7.9 grams. It's our excess reactant. So 7.9 grams would be the answer to how much is wasted. And that's how we do those sorts of problems. Let's go ahead and I'll review this one, and then for the next one, you'll have to do it on your own. Determine the mass of tetraphosphorus deck oxide P4O10, which is formed from 25 grams of phosphorus and 50 grams of oxygen. Probably not intelligent amounts, so we'll have to figure out which one is the limiting reactant. Well, thank God somebody figured out that it's 123.9 for the phosphorus. There it is. And O2, yikes, that would be 32 times 5. I'm going to say 160. So for every 123, we require 160. We need more oxygen. Do we have more oxygen? We do, and we have twice as much. We have excess oxygen. I believe that phosphorus is the limiting reactant, and I'm going to hang my hat on that. If I wasn't sure, I would do both 3-steppers, both for phosphorus and for oxygen. Circle the lower number. But I'm in a hurry, so I'm going to assume I'm right. And let's figure out how many grams of product it can make. That's a 3-step conversion. 123.9 grams is a mole, meaning 4 times the atomic mass of phosphorus. And for every mole of P4, we make 1 mole of P4O10. There it is, balanced. And what does it weigh? 283.9 grams of product, and that means we have enough to make 57.3 grams of P4O10. In this problem, they're going to ask you how much the excess remains. Had they asked this for this, I would take either this number and find out how much, let's see, oxygen it required. The rest would be excess. Or I'd take that P4 and find out how much oxygen it requires. You'll get the same number either way. Good luck with problem number 2. This is Mole Worksheet 5.